Okay, I'm live. Oh, all right, my live preview actually loaded. And let's make sure that OBS is setting to sound. Looks like it is. Perfect. Minimize you. All right, so happy Monday. Welcome back. Time for another work week, and also time for more learning of Rust. So last week I created, what was it? No, I updated the Fahrenheit to Celsius and vice versa. So the temperature converter application that we had made originally way back in chapter 3, we updated it to use enums. Now, I got a little bit confused, and my enums were like a little bit questionable, not that great. But you all sort of stepped in and helped me out. So let's see if I have. Yes, I have some. Two of you have given me some things to look at. Danny, Fritz, to begin with, you gave me some really awesome pointers here, which was if I could just get the temperature first, that's sort of like I made the rookie mistake. And let me actually get my code up here first, and then we can talk about the differences here. So cd projects mine. Okay, so open up over here. So if we take a look at our code here, what we have is, okay, I only made it Fahrenheit and Celsius. Now, the reason why I had done that was because, oh man, I don't have the actual temperature itself. I mean, I'm getting the temperature first, but I'm getting this symbol second. So how could I possibly put the temperature into here if I don't have the symbol? I could just do that. If I did this and got the symbol first and just accepted that this is going to come in as a variable, then I can create the enum straight here. Because now I'll be able, like, it's coming in as an F32. I'll be able to throw it into the enum temperature. So, also, thank you for letting me know there's an update code. Okay, so that's one thing here. Another one was a suggestion of putting the convert inside of the implementation. So that way it implements this implementation for temperature, converts, and then I got a lot of this like, okay, here's how to use your reference self. Because I had a little bit of trouble getting that. It's like, it wouldn't let me do it, but I think I just did it wrong, which seems to be like a very common thing with Rust when we're learning. But that's not a problem. I'll get it right eventually. So then we're gonna we return a new temperature, and then we can now match on Fahrenheit or Celsius, get the actual, get actually what it is, and then replace here. And then format. And so then the next thing was bring in standard format, which I don't think that we have covered like these type of traits yet in the book, but from what I can tell and from Denny's description, we are setting a custom display trait for temperature, so that way we're basically saying this is what's gonna go, this is what's gonna happen, this is what it's gonna look like, and that way we can now print all of these. So there's this. Now this was an issue. A pull request has been made as well by Avarice. So this pull request is bringing in standard IO and standard format. I don't believe, did I bring in either of these? I brought in standard IO. So to begin with, if we take a look, okay, we have our temperature, and we're going to use Fahrenheit, which is a floating 32, Celsius, floating 32. Exactly the same as what Danny had. The difference here is that we're copying over these, the derive, clone, copy, and debug. So I'm not exactly sure exactly what, we saw what, like debug before. I don't know exactly what clone or copy is doing. Like, is that actually copying it from the other, like something else? So I'm hoping the book will cover this in a little bit more detail. And then our implementation for temperature is a little bit different in this one. So this one is a convert in place where it takes a mutated reference to self. But then it has this use temperature, and this brings the variance of temperature into the local scope to simplify matching. So I had never really thought to use inside of a method or a function, because like we use up here, but that's just for the global scope, or at least the global scope for this file. So once we're in here, now we can match on the self and then say, okay, well, here's our Fahrenheit arm, and we're just going to set self, because it's mutable here, we're now going to assign it to be this. So whatever temperature is, it now is still itself, but it's different. Like, instead of being Fahrenheit, now it's Celsius. And so I think like this is, I think this is one of the things that I was asking about is like, can I switch around between them? And the answer is yes, and to do this, to create a method that sort of mutates itself. Now, convert to new, so this one, okay, we're using temperature again, and this one is, okay, we're now returning a full new Celsius or Fahrenheit. Now I think, is that temperature, so temperature colon / that's allowing us to just not do temperature colon Celsius there, I believe. So that's, yeah, to simplify matching. We're just less characters in these lines. Okay, so convert to new is like, this is convert in place, this is convert to new, and then is Celsius is just going to say like, hey, is if let temperature Celsius, and we're ignoring, like, we don't really care what the content of it is. It goes into self, and then we just say, then we just return true or false. If Fahrenheit is just the opposite of is Celsius, so it's not self is Celsius, which I thought that was that's a like little tricky one to do. I probably wouldn't have thought of doing this one if I had implemented it, and would have just had the opposite of here. Okay, so we'll want to implement the display traits for our enum. So here's our implementation of display for temperature. And so I haven't seen this before, because previously it's just implement of temperature. So implement display for temperature is new to me. And then here's where we just say function format. And so this is a little bit interesting of bringing in the reference to self, and then variable f, which is type format formatter, which we had brought in at the very top, so format. And then we're going to return format result. So I think this is how we set up the print down at the very bottom, like how we're going to get it to print properly. Now this is pretty much the same as what Danny had. Okay, and then we have our main, which is print line, temperature converter, let temperature equals get temperature. So now our GetTemperature is, as I believe, going to return an enum. And of course, we have our print lines. All right, so GetTemperature now returns the enum temperature. So we're gonna say let mutable, so create variable buff or buffer. This is gonna equal to string new, and then he says we'll reuse this buffer for all of our input. Then we call GetUserInput like we were before. What is the temperature you want to convert? And we pass in the buffer. So instead of user input now returning returning anything, it's now just going to take in a reference to a mutable place in the heap and update that. Or I guess, would it really be? Yeah, it is, because it's string new. Okay, so let temperature equals buffer.trim.parse. So now we're converting that to a number, and if not, we give this text. Okay, so GetUserInput, is this a temperature in C or an F? So now in GetTemperature, we're doing both of these things. So unlike what I did here, which was in main, I got the input symbol and the input temperature. The idea is that I had a GetTemperature where I did all of this stuff in here and then returned the enum. Okay, so we find out what we're using. What's interesting is that we're using, okay, this buffer is being used now in both of these because we're just handing it to it and it's going to be overwritten now. Okay. So what's also interesting is that we're having a temporary variable. Now it's going to hold, what is it? It's going to hold the borrow, because I believe trim and parse returns a reference to a stir. So let's see. GetUserInput is this temperature, and see, we hand it the mutable buffer and match buffer trim. So we take whatever was buffer, we trim it, and then we match the result to the trim. So we're gonna get F or C. Now I was doing these with single quotes instead of double quotes because I was checking characters. But now we're not checking characters anymore. Now we're just checking full, well, stirs, it looks like. And then we'll say, okay, temperature, if it's like one of these, we create temperature Fahrenheit and the temp. And same with C. And then if it's not either of those, we're gonna call the panic. Oh, it's not a method, it's a macro. Call a panic macro and then tell them, hey, you need to enter a C or an F. And then finally we have our GetUserInput, which takes in a message string and buffer. So provide buffer for read line to read into. We need to buffer clear to remove any old content in the buffer. So message, stir, buffer are these two things being passed in. Let's go back to where we're calling GetUserInput here. And we're passing in the message and then mute buff, which was this right here. So it's been passed in, it has old data in it. So the first thing we need to do is clear that out. So once we've cleared it out, then we can print this message, and then we're gonna say, okay, well, this is an attempt like, hey, if, Okay, we attempt to flush standard out. And if that doesn't work, could not flush standard out, and that will quit the program. And then we read the line. We pass it in the buffer that it's going to come into, and then we have our expect. We couldn't read the line. And that's the end of this program. So it's doing, for the most part, the same thing. But both of these, both from Averis and Danny, have the same general idea, which is we want to get the input symbol and the input temperature together at the same time so that we can create the enum. And then once we have the enum, now we can, put the methods that we want on the enum to do the interesting things. Hi, Averis. Welcome to the stream. I was just going over the pull request you created for the temperature converter. So we have there's a whole lot going on here. So what I think that I want to do to sort of like preserve what I have and then potentially pull this in is I'm gonna come in here. This is using enums, and you pulled this into using enums. Perfect. I am now going to get status. All right, we're up to date. I'll just pull just in case. Nope, I didn't work on any other computer. All right, so get checkout -b, and I'm gonna call this new branch original using enums, and get push -u origin original using enums. So now my code is in here. Only after I created the PR said that someone else opened the issue doing basically the same thing that I did. Yeah, that's okay. That kind of thing happens. But now, so I have my original. So if anybody wants to come and sort of see like what I had done, they can explore that and run the code and see that it works. And I am going to also pull in this to the using enums. So merge the pull request. So now this is also in there. So now you can compare and contrast these two branches if you so desire. So if we take a look at our code, yes, I know I have original. I don't want to pull that in now. So temp convert source. Now we have this sort of new version. Now, there are some new things that we haven't learned in a book yet that are in both of the versions that Danny suggested. So in here, I'm going to give this the label. I kind of want to create information. Which is exactly the same one that I'd put onto like the other ones in the learning Rust. So that way people can know like, hey, this is informative and helpful too. And even though I know the Averis you did like, and it's very similar, there's some slight differences in implementation of how Danny did it and how you did it. So I think anybody coming in, and me too, like coming in and be able to see the difference between both of these will help us in the future as we decide, well, which way do we want to go? Okay. So how would I do mine differently now knowing this? I would probably come in and say, and And just like you did, Avarice, I would move in getting the temperature symbol from into GetTemperature. And then I would just return a temperature. Then, and I would just have to use a random, like a temp variable, like a temp variable, because it's temporary, and a temperature. I need like a soundboard for a really terrible joke. Okay, so then we have our get, then a lot of these will be the same because get temperature symbol, get user input can remain the same. Now I don't think I would implement like definitely yours, Avarice, right now because we haven't covered that in the book and I don't like understand fully what's going on there, so I don't want to use it too much. But it's nice to know, hopefully, that we'll eventually be going over that, and then I will understand that. And now this convert F to C and C to F, I kind of do like the idea of removing these from here and putting them into the implementation of temperature. Now, because you two have those great explanations, I don't think I'm going to necessarily do that. I'm going to leave what I had here and then move on from there. So don't save. We'll close this. Anyways, that was 20 minutes of me talking about some really awesome help that I got. I also want to, before I forget, put Avarice into, let's see, it's the Learning Rust. Oh, document projects. I'm in the wrong directory. Learning Rust here. We'll open this up. And in the README, okay, so we're gonna add in at where did, I guess I need to come fully into here to see that Avarice's username. Oh no, it's not in here. Okay, hold on. Why is this under my name? Isn't this yours? I feel like GitHub makes it hard to like find who did what sometimes. Okay, so let's go back to the code. Or is it because I accepted the pull request? I don't know why it's giving me credit for that. One contributor. Okay, that's just me. I'm on the wrong branch. I am on the wrong branch. You're right. Using enums is what I want. Yes. Okay, merge pull request from this. But if I come in here, here we go. Oh, come on, just let me accept. Okay. Let's just go to your account. Fine. Copy it this way. And there. Avarice, and then you sort of, you helped out with the F to C. So perfect. Save. And we'll update. Got some awesome help from Avarice. Boom. And push. Okay, almost 30 minutes in, and we can now continue on with the book. So where were we anyways? We're finished with chapter 6, which means we can now move on to chapter 7. Okay, so I'll probably be quitting that, creating a new one. Let's go find the book. second edition. Chapter 7, modules. All right, so we'll see how far we get into this. Using modules to reuse and organize code. I know like this is like this is a huge aspect of like all programming, because it's, you know, kind of important not to have to put all of your code into a single file, because that would be terrible. When you start, also I can full screen this. When you start writing programs in Rust, your code might live solely in the main function, which I think for some part they've been expecting us to do. As your code grows, you'll eventually move functionality into other functions for reuse and better organization. So we've got that part. By splitting your code into smaller chunks, each chunk is easier to understand on its own. But what happens if you have too many functions? Rust has a module system that enables the reuse of code in an organized fashion. In the same way that you extract lines of code into a function, you can extract functions and other code like structures and enums into different modules. A module is a namespace that contains definitions of functions or types, and you can choose whether those definitions are visible outside their module, public, or private, or not private. Here's an overview of how modules work. The mod keyword declares a new module. Code within the module appears either immediately following this declaration within curly brackets or in another file. By default, functions, types, constants, and modules are private. The pub keyword makes an item public and therefore visible outside of its namespace. The use keyword brings modules or the definitions inside modules into scope, so it's easier to refer to them. We'll look at each of these parts to see how they fit into the whole. All right, so moving 7.1. Mod and the file system. We'll start our module example by making a new project with cargo, but instead of creating a binary crate, we'll make a library crate, a project that other people can pull into their projects as a dependency. For example, the rand crate discussed in Chapter 2 is a library crate that we used as a dependency in the guessing game project. We'll create a skeleton of a library that provides some general networking functionality. We'll concentrate on the organization of the modules and functions, but we won't worry about what code goes into the function bodies. We'll call our library Communicator. By default, Cargo will create a library unless another type of project is specified. If we omit the -- binary option that we've been using in all of the chapters preceding this one, our project will be a library. Is that how it still works? Cargo new communicator. So let's actually try that. So we're in Learning Rust. I'm just going to do it here. I'm going to take Chapter 7 and cargo new communicator. Created binary application communicator project. So is that what we were expecting? Like binary application? Or did we want it to be a library? Just out of curiosity, I want to try this. So cargo new -- bind testing. So created binary application testing project. So I don't see any, yeah, this changed recently, Avra says. So yeah, so this book is wrong. Do they accept pull requests on this book? Or maybe I can find where the code is and do an issue for it. So I'm gonna remove the testing and remove the communicator. So let's take a look at man cargo.new. man cargo. Cargo dash H. There we go. Okay, so some common cargo commands are see all commands with dash dash list. So build, check, clean, doc, new. Create a new cargo project. But they don't have, like, there's no dash dash bind or anything else. Okay. I think they do accept PRs. Nice. Install a Rust binary. Well, we need to figure out like how to actually do it first. So there is this new. So can I do cargo dash dash list? That's just all installed commands. Can I do cargo help new? Ah, I can. Okay, perfect. All right. Create a new cargo package at path. And new options. Right. Dash dash binary or dash dash library. Use a binary application, which is now the default, whereas library is use a library template. So if I do cargo new dash dash lib and then communicator, created library communicator project. All right, perfect. Now let's go see where that is and create an issue for it. Because I know if I don't do it now, I'll probably never do it. And I want to make sure at least somebody is aware of that on the project. So Rust book, is that good enough of a search term? Can I find like the Rust language? There's too many. It'll be too hard for me to figure out like which one is actual official. Ooh, wait, Rust lang. Code examples from the book Programming Rust from O'Reilly. That's not the same. Okay, so maybe I'll just say Rust. Oh, there's too many people. Rust lang. Ah, still too many people. Let's go to the actual rustlang.org. Let's see if I can find rustlang/book. Also, contribute. All the bug reporting guide. Rust is expensive. Rust project developers. Rust lang organization. So perfect. Yes. And then, as you said, the book. And then I want version 2 of the book. Is that master? This repository contains the source of all editions of the Rust programming language. The second edition will also be available in dead tree form. Okay, May 2018. Oh, that's like now. You can read all editions for free online. Yes, yes, yes. Okay, how to build it. Let's also take a look at their issues. Is there, can I look for maybe cargo? Cargo now creates binaries by default. So that's exactly what this is. In a second edition of the book, when creating binaries of cargo, the book makes it explicit with cargo new binary and tells it that if not specified, cargo created a library. However, this is no longer true. One of the so has where this is. there is a pull request already. The second edition is the way we want it for print. But this pull request will address it for the 2018 edition. All right, well, it sounds like it's already been done, so I don't need to worry about that. Let's get back to the book. All right, so we're going to create the library communicator, cd into it, and open up code. And turn off this as soon as it shows up. I should go in and figure out how to turn off auto updates, like the auto update notifier from code one of these days. Or I'll just wait for it to show up eventually. Notice that Cargo generated source librs instead of source main.rs inside of source. Inside source librs, we find the following. So mod tests. So interesting. This is a trait, right? So configure test, mod tests, and then this is a specific test. It works. Assert equal 2 plus 2 is 4. So it gives us a nice little a canary test to go on too. Let's make sure we have that. So source, yes, indeed we have that. Cargo creates an example test to help us get our library started, rather than the hello world binary that we get when we use the --bind option. We'll look at this hash open close square brackets and mod test syntax in using super to access a parent module section later in this chapter. But for now, leave this code at the bottom of source librs. Okay, so we're going to leave it in the bottom. Because we don't have a source main.rs file, there's nothing for Cargo to execute with the cargo run command. Therefore, we'll use the cargo build command to compile our library's crate code. We'll look at different options for organizing your library's code that will be suitable in a variety of situations depending on the intent of the code. Module definitions. For our communicator network library, we'll first define a module named network that contains the definition of a function called connect. Every module definition of Rust starts with a mod keyword. Add this code to the beginning of the file above the test code. So mod network function connect. So well, for I guess not connect to something that we're going to do later. So let's go ahead and do that. Mod network function connect. Now I think they also said we're going to have to make it public. So mod network, and then this is just curly brackets here, and then function connect. Of course, it's going to yell at us that we're not using it. All right, after the mod keyword, we put the name of the module, network, and then a block of code in curly brackets. Everything inside this block is inside the namespace, network. In this case, we have a single function, connect. If we wanted to call this function from code outside the network module, we would need to specify the module and use the namespace syntax : like so, network : connect, rather than just connect. We can also have multiple modules side by side in the same source lib.rs file. For example, to also have a client module that has a function named connect as well. We can add it as shown here. So client also has a connect. So mod client, and we have a function connect. Now we have a network connect function and a client connect function. These can have completely different functionality, and the function names do not conflict with each other because they're in different modules. They're essentially namespaced. In this case, because we're building a library, the file that serves as the entry point for building our library is source lib.rs. However, in respect to creating modules, there's nothing special about source lib.rs. We could also create modules in source main.rs for a binary crate in the same way as we're creating modules in source lib.rs for the library crate. In fact, we can put modules inside of modules, which can be useful as your modules grow to keep related functionality organized together and separate functionality apart. The choice of how you organize your code depends on how you think about the relationship between the parts of your code. For instance, the client code and its connect function might make more sense to users of our library if they were inside the network namespace instead, as in listing 7.2. So file name, source lib, right, because we can have mod network function connect, mod client function connect. Right, because this is like, and network has, well, server for this and client. Wouldn't I want to do like a mod server? So network server, I'm not sure. Do they want us to actually do this, or are they just giving us an example? I don't think they are. In your source lib.rs file, replace the existing mod network and mod client definitions with the ones in listing 7.2, which have the client modules and an inner modules network. Nope, they definitely do want us to do that. So we have mod network, which has function connect, and then we're going to put mod client inside of here. So now we're going to have, now we have exactly what they want. And I should make sure I save it. Now we have the functions network connect and network client connect. Again, the two functions named connect don't conflict with each other because they're in different namespaces. In this way, modules form a hierarchy. The contents of source lib.rs are at the topmost level, and the submodules are at lower levels. Here's what the organization of our example in listing 7.1 looks like when thought of as a hierarchy. Communicator, network, client. Oh, okay, I was going to like, but isn't client in network? That's literally the next one is communicator, network, client. The hierarchy shows that in listing 7.2, client is the child of the network module rather than a sibling. More complicated projects can have many modules, and they'll need to be organized logically in order to keep track of them. What logically means in your project is up to you, and depends upon how you and your library users think about your project's domain. Use the techniques shown here to create side-by-side modules and nested modules in whatever structure you would like. Moving modules to other files. Modules form a hierarchical structure, much like another structure in computing that you're used to, file systems. We can use Rust's module system along with multiple files to split up Rust's projects so that not everything lives in source lib.rs or source main.rs. For this example, let's start with the code in listing 7.3. Okay, so we have mod client, mod network. Oh, interesting. So we have mod client connect, mod network, mod server. Okay, that's also interesting. So network is going to have a server in here, and then we're going to have, and they're just connects all around. And then mod client with a function connect. I just reversed them around, but I don't think there's a difference. The file source lib has this module hierarchy, client, network, and server. If these modules had many functions and those functions were becoming lengthy, it would be difficult to scroll through this file and find the code we wanted to work with. Because the functions are nested inside one or more mod blocks, the lines of code inside the functions will start getting lengthy as well. These would be good reasons to separate the client, network, and server modules from source lib.rs and place them into their own files. First, replace the client module code with only the declaration of the client module so that your source lib.rs looks like code shown in listing 7.4. So instead of mod client with the block and everything in it, it's just mod client, like declaring the namespace. So we'll just do this. And you're yelling because file not found for module client. It wants now client rs to be existing in here. We're still declaring the client module here, but by replacing a block with a semicolon, we're telling Rust to look in another location for the code defined within the scope of the client module. In other words, the line mod client means mod client, yeah, well, yes. I can figure that out. Let's see. Now we need to create the external file with the module name. Create a client.rs file in your source directory and open it. Then enter the following, which is the connect function in the client module that we removed in the previous step. So we don't need the mod anymore. We can just do the plain connect. So let's do that. Inside of source, we're going to create a new file and call this client.rs and function connect. Save this. And now if we come back here, yeah, you're no longer red because you found this file. Note that we don't need a mod declaration in this file because we already declared the client module with mod and source lib.rs. This file just provides the contents of the client module. If we put a mod client here, we'd be giving the client module its own submodule named client. Rust only knows to look in source lib.rs by default. If we want to add more files to our project, we need to tell Rust in source lib.rs to look in other files. This is why mod client needs to be defined in source lib.rs and can't be defined in source client.rs. Now the project should compile successfully, although you'll get a few warnings because we're not actually doing anything. Remember to use cargo build instead of cargo run because we have a library crate rather than a binary one. All right, so let's give that a shot. Cargo build. And then we have the never used, but it found that. Doesn't say anything about our test. So before we go in there, I bet if I make this test fail, so if I put this like a 5, cargo build, oh, it doesn't care. So it's not actually running these tests. I wonder, is there like a cargo test? Cargo -- list. There is. So cargo test. That runs our test. So running one test, it works. Failed. Basically, left is 4, right is 5. They're not equal. Perfect. So that will make it so the next time we run this, everything works just fine. Although we still get these warnings because we're not actually using that code. These warnings tell us we have functions that are never used. Don't worry about these warnings for now. We'll address them later in this chapter in the Controlling Visibility with Pub section. The good news is that they're just warnings. Our project built successfully. Now let's extract the network module into its own file using the same pattern. So network is going to go into its own file as well. So here's network. I'm going to grab this. Now we can make this all very close to each other. We'll look for network.rs, paste this in here. So we have function connect. Now the mod server is probably perfectly fine because it's a mod inside of network. But we can probably do like mod server and then have that as an external file as well. I wonder if that's what's going to have us do next. Okay, so we move these in here. Run cargo build again, success. We have one more module to extract, the server. Because it's a submodule, that is a module within a module, our current tactic of extracting a module into a file named after that module won't work. We'll try anyway so you can see the error. So, okay, so first I'm going to do the cargo build. I didn't screw anything up, so we're good there. And now we're going to create, so we're just going to do, come on, mod server, and we just function connect. And where is it looking for it? File not found for module server. So server.rs function connect, save, file not found for module server. Name the file either network/server.rs or network. So yeah, so it's looking for it inside of this. So we can see that that's the error that's going to come in. Due to configure test, the whole test module won't get compiled unless you run cargo test. Thank you, Avarice. Okay, so we saw this. It says like, hey, you need to go inside of network. There says that we cannot declare a new module at this location, and it's pointing to the mod server line in network source. Wait, is it different error than what we got? Cargo build. So I feel like the error that we got here is not exactly the same as the error that we have in this book, but I think maybe things changed slightly, but it's a little bit more clear, I think, the errors now. Okay, so we need to create a new directory. So instead of continuing to follow the same file pattern, we can do what the note suggests. Make a new directory named network, the parent module's name. Move the source networks rs file into the network directory and rename it to source networks mod rs. Move the submodule name into this. So are we sure that this is exactly how to do it? Make dir source network rs, and source network mod rs. Because I feel here it's just saying name the file, so mod server, name the file either network server rs or network server mod rs. So I think that what I could do is just so take network, and then I want to move is that a directory? Network is a directory. Okay, so where did I want to put this? Oh, I'm not in the right one. So hold on. Remove .rf network. Oh, I'm inside of it. Remove -rf network, cd into source. do all their stuff in here. So take network, and I want to move server was it server that I wanted? Network server, yeah, server into here. So there we go. Let's do cargo build. Okay, so mod server up on stable builds. Rename this file to network mod.rs. So it told me before, oh, it can be either, but now it's saying that I want to move server to mod.rs. Cargo build. Cargo build. Delete or rename one of them to remove the ambiguity. Mod network. So in lib.rs, oh, file for module network found at both network.rs and network mod.rs. So that's the problem we have here, which is make a new directory named network. Because, okay, so move source network rs into source network / mod rs. Move source server rs into source network. So, because I have network down here too. So they want us to move network rs into network mod rs. So move network.rs into mod.rs. I screwed that up. Move mod r to mod rs. That overwrote the other one, but I'm okay with that. And now we want to say, so that's network, and then we just want to have server be brought into here. So now we're going to touch server.rs inside of here. And in network server rs, we can now have function connect. Save that. Now everything should be happy. Cargo build. Everything's good now. But that's because of like those interesting sort of names. Now when I try to run cargo build, it will work. We'll still have warnings though, but that's fine. So we wanted to extract the network server module. Why do we have to also? Well, it's because of those name changes, because we have like network, and it got really confusing. So what I'm going to do is I'm going to say, okay, rules for module systems is what we're going to be doing next. I'm going to go ahead and close you. And let's come here. Learning rest. So let's vim the README. Currently at. So we are now at chapter 7.1, rules of module file systems. Okay, so we've got this here. I'm going to save this, get status. Looks like we have the appropriate stuff that we want in here. So now let's git commit -m starting chapter 7 and a git push. All right, it is 8 o'clock, which is going to be the end of this morning's rest stream. I feel excited getting into modules and like potentially further on. It looks like a lot of the stuff that we have been talking about in previous streams are going to be covered hopefully shortly, but maybe later. We also found that bug in the book, but it looks like the Rust team is already on it. They even already have the pull request, which is going to be accepted. So what I wanted to do was find this tweet here. Go to that. So I have I believe that this is the correct link. I still have the poll going for where to stream, which is on YouTube or Twitch. So there's positives and negatives to either one. YouTube has a huge programming audience. YouTube, like a lot of people come to YouTube, including me, for like, hey, let's look through tutorials or other things on programming. On the other side, Twitch has a better sort of infrastructure for the actual streaming and the chat systems. For example, like only I can put in links into chat, which kind of sucks a little bit. I can't even allow anybody to put a link in. Code is like terrible also because it will detect that and just remove the code. So what I've been sort of trying to think about what the best ways are, and I see it as two options, which is switch to Twitch or switch back to Twitch for myself, and then we can take archives and put that onto YouTube. The other option is to stay on YouTube, but then maybe build some kind of application. Maybe by the end of this book, I'll be able to get create something like a program that everybody can download, put it onto their computers, and they can submit snippets to me through that program. So basically outside of the chat. I think both of those might end up being like, they're both viable ways to do it. But I believe that I now have live chat replay. So if you're watching this in the chat, there should now be a link to a specific poll. It's on only for like the next 9 or 8 hours or so. So if you're seeing this like a day or two after I made this video, the poll will be down, but you'll be able to see what people put in. Other than that, this has been a good fun stream. I'm glad we sort of went over all the code updates and we started on chapter 7. Anyways, if you enjoyed this content and you want to see more, please follow the channel and get updates from it. I'm streaming these every single weekday morning at 7 a.m. Mountain Time. And with that, I'm going to go prepare for the rest of my day. So I hope that you all are having a great day, and I'll see you next time.